All right, so you asked about 9 and 10. I'm just going to go through the series because they're all related. So in this experiment, we put ice into water. Okay, the water transferred energy to the ice melted, and then the ice heated up. Okay, the ice originally started at 0. Okay, and then the final temperature of the original ice, which is now liquid and water, is 22. So if we look at how much energy does the original water, which was 125 grams, lose? So it went from 45 to 22. So that's Q equals MC delta T. And so that's going to be 125 times 4.18 times, goes from 45 to 22, so it's negative 23. Okay, so I'm just putting in the calculator, 125 times 4.18 times negative 23. I get negative 12,017.5 joules. Okay, so what's the total energy gained by the ice? It's that same quantity, just positive. So 12,017.5 joules, because the energy that was lost by the water went to the ice. And it says how much of the above energy comes from a temperature change. So the ice did two things. It changed temperature and it melted. Okay, so we're not going to use the 334 here for heat of fusion. We're trying to calculate it. That was the purpose of our lab. Okay, so the first thing we want to do is from 8, how much was the temperature change? So, well, how much ice did I have? So that's the first thing. So if the water volume, or actually mass, was from 125 to 153.9, so I'm going to do 153.9 minus 125. The increase came from the ice melting. And so that's 28.9 grams of ice. So now the temperature change energy would be from MC delta T. So that's going to be 28.9 times 4.18, because it changed temperature as a liquid, times it went from 0 to 22. So times, that's 2,657.6 joules. All right, so now to your question, okay, how much energy caused the ice to melt? We're not going to use the 334 here. That was the purpose of the lab. We're going to take our answer from 8 and subtract it from 9. So 12,017.5 minus 2,657.6 gives us 9,359.9 joules. That was the energy to melt. So we want to calculate the experimental heat of fusion. Okay, so we take that energy, sorry, that's not negative, that's positive. Okay, it was melting. So I'm going to take that energy now, and it's Q equals MHF. So 9,359.9 equals 28.9 times X, and our experimental value is 323.9. And then the next problem, you want to calculate percent error. That's where this is our experimental value. Okay, and then the 334 is the accepted value.